Well, Assalamu alaikum again. So this is palindrome. In this video, I will discuss about a problem from Codeforces Round 874 Deep 3. Problem number is G. I can't announce this name, so let's get started. So let's start with the statement. So let's first of all let's standard the problem statement. So in this problem, you will given a tree. All right, you have to cut edges of this tree in such a way such that after cutting a edge, rest of sub tree contains a branch, right? What that is means, let's assume that you have a tree 1 2 3 4 5, all right, 6. Let's assume this is your tree. So that's they are your age, right? You can uh, cut it, right? You can cut its edge. So you can cut this or this as your wish, but you have to cut such a way such that after each cut, rest of the tree will contains three vertices, which they have called branches, right? All right, so let's take this example, which is this. Now if you cut these vertices, then this is a subtree which number of vertex is 3, so it is a branch, and this is another branch consists of 3 vertices, and this is another branch. So you should cut this and this edges. So you have to print this edge number, right, which is uh, 2 and 8, and how many vertices, and number of vertices 2, and the answer is 2 8. All right, and when the answer is -1, see this example, 1 2, 1 is connected with 3, 4 is connected with 3, 1 is connected with 5, and 6 is connected with 1. So this is very obvious that in this tree it is not possible cut edge such that every branch will consist uh, 3 vertices. So let's assume 4 3 1. I have to cut this and this will be our a branch, but this not a branch, and this is not a branch, and this is also not a branch. So in this case answer is -1. So I hope uh, you get the point. That means I hope you um, you have understood this problem. So how can we solve it? Okay, right. So we have taken a tree of 9 vertices, 9 vertices. So the first observation is here: if our given n, that means the number of node, if our n is not divisible by 3, then answer is always -1. It is for sure. All right. So we will handle this case in such a way. So after all, we have now n is only modulo of 3. So we have such n such that which mod value is always 0. That means n is divisible by 3. All right. So here is our we have taken this tree, right? So how can we cut the edge, right? So let's assume 9, 5 and 1. This is a branch, so we can cut these vertices, edges, and go for this, and this is a branch. We can cut this edge, and rest of this is always also a branch. So in this case we have no need to uh, so in this case we have not no need to cut any edges. So how can we solve it? All right, so for solve this problem we will consider some case. Let's assume we are in a node whose name is x1 and it has no children. It maybe have parent, but it has no uh, children, right? So in this case we are not interested to cut this edge, or it is not possible to cut. So this is one case. So another case is our node x1 have one children, which is x2. In this case also we have not way to cut these edges, so it will be like this. And next example, you can see that x1 is my node and it has two children, right? So in this case I can cut its parents edges, right? Let's say its parent name is per, which is a node, and I can cut this, right? Well, and for this kind of configuration where x1 is connected with two children, it is also possible to cut its parent edges. And let's move on to the another example, which is important one. See, x1 is connected with x2, x3 and x4, right? Here x2, x3 and x1, it may be a branch, so we can cut its parents, we can say parents edges, but we are rest of this x4, right? So we can't distribute it any branch, right? And again for this example you can also see that x1 have three vertices is in its subtree, but if you take this as a branch, x4 will be your rest element which is not included in any branch. So how can you distribute it, or how can you say that it is not possible, right? So what we will do that x1 is connected with x2, x3, x4 and x5, right? If x2 having only one node and x3 having only one node, then this x4 should be some vertices such that number of vertices is divisible by 3. That means x3 can connected with 1, 2, which is connected with which is a divisible by 3, so it is not problem, it can be a branch. And x4, x5 also should connected with such nodes such that this also can be a branch, right? So if my node is my node subnode is just one, then it can be connected with at most two nodes which sub tree size is 1, right? Which is 1 and this is 1, right? Not more than this. So for every child of x1 I will calculate my subtree, right? That means x1 for x1 I have calculated 4 subtree, right? X 1 2 3 and 4. For x1 it will be 1 subtree size, x3 it will be 1 1 1, and for x4 it will be 3, and x5 it will be 3, right? But for this case I will not uh, um, I will not fill with 3, I will fill with 0, and for it 0. If there is any other element x6 which is connected with 0, a node, and this is connected with a node, and let's assume there is 6 node, right? 1 2 3 4 5, and this is 6, so this will be 1 and this will be another one, right? So for divisible by 3 I will just put 0, right? 1 1 0 0, right? So I will not take in my storage, I will just store 1 and 1, right? So for this kind of configuration where my children gives me 2 nodes which have value 1 and 1, in that case I can remove, let's assume p is its parent node, I can remove this index of p and x, right? Let's assume I have stored index of p and x1 is my in id map, so I can store it, right? I can cut it, right? All right, and if I am rest with just x1 is connected with this x2 which two node which nodes subtree size is 2, right? x1 subtree size is 2, right? Then it is obvious x3 should also be either 3 6 9 or divisible by 3, right? Its size should be 3 6 9 or divisible by 3, anything, but it can't be 1 or 2, right? For 2, that means for 2 this is obvious that there is only one node is possible, or only one child is possible, which number of node in subtree is 2, and this will make a branch with x1, that means this x2 is this is 2, and this will generate a branch with this, right? That means in this case I can also cut the edge id of p of x1, right? All right, so for this case let's understand this. So I have run a DFS from 1, so 1 2 it will be go 5 and then 9. So 9 is 9 have no children, so I have just written 1 here, that means its size is 1. All right, 5 have 1 children which is size is 1, I have stored it there, and it has no children more, so I have just written 1 plus this size 1, so it will be 2, right? This for, and for 1 there is two children, right? One size is 2 which is this, and rest of size I don't know what is this size, right? So I will go for 6 and then 7 then 3. Now for 3 I will return 1, and 7 for I will go for 2, and I will return 1 here also. So in this case 7 has 2 children which value is which subtree size is 1 and 1, which is a condition I have written there. 1 and for 1 and 1 I can make a branch with the parent node, right? So I can make a branch with this 7 3 and 2 and cut this. All right, So for this 7, I have make a branch, so I will just return 0 here, right? I have told you that if I can make a branch, then I will just return 0, right? Alright, then 6, for 6 I will go 8 and go 4. 4 I will just return 1 here, and 8 have no children, just 1 children, so I have done 1 plus 1, which is 2. And for 2, if I have told you that if I have a subtree of size 2, then I can make a branch with this node, that means parent node, which is 4, 8 and 6, which is a branch, and I can cut these edges edge, and I can return 0 from here. So one have two branches, right? Two children, one children subtree size is 2 and another is 0, so I will not consider this 0, I will just take 2. So for 2, uh, this 9 and 5, and I have below I have node 1, so this is also a 2 plus 1, which is 3, and this is also a branch, so I can uh, generate a branch also. So in this case I can handle the tree, I can solve this tree. So let's take another example. Let's see, this is my example, this case, sorry, this case, right? So what is this? 1 with 9, 1 9. So well, I have drawn this tree. So let's see how it is possible or not to make such cut. So I have started DFS from 1 9 6 and 2, it will return 1, and this will return 2, and since this is 2, so it can make a branch with this node, so I can just remove this edge. So this is my branch, right? So let me elaborate it. So I have just, for this I am not cutting this time, I will cut it uh, in future. Let me store this 2 here, that means for one children, it I have found a subtree which size is 2, right? Then 9 I will go 7, then 3 it will give me 1, and this 4 will give me 1. So here I have found it subtree which have two children, 1 and 1, so I can uh, make a subtree which size is 3, taking this 7. So I will just return here 0, right? So this 0 will not include here. So for this 9 I have found a 2 just, so I can add 1 also from by adding this 9, so it also be a size of 3 length, and for 1 I will go 8, and this will return also 0, right? 1 8 and 5, this will return 1, and this will return 1, right? 2, right? 1 plus 1 is 2, so this is also a branch, right? So let's take an example which is not my which answer is -1, right? All right, for this, so we have 1 for 3, and we have reached 4, and return 1, from this return 2, right? So I have stored this 2 here for node 1, right? For node 1, and we have go 5, and it will return 1, so we have written this one here, and for this 2 you can also return 1, and this 6 it will run 1. And now for this one, we know that if we have just 2 as a children subtree size, there must not be any children which side is greater than 0. so it is not possible here, right? For one we our for one child for one its subtree size may be just 2, right? Such that we can make a group using this node and its subtree, right? Or it may be, for one it may be 1 and 1, right? That means children size may be 1 and another children size may be 1, so it also uh, make a branch, right? It can also make a branch with this node, but rest of other case are not allowed for us, so in that case answer is -1. But as I told you, if one is connected with just almost a1, so in this case I will not uh, say that answer is -1. We will just add this one with our um, node size, right? Which we have done this here. For 3 we have, for node 3 we have um, got a child which size is 1. We have not say that our answer is -1, right? We have just add it with our uh, subtree size. So okay, in this way we can solve it. So let's have a look at our code. So at first we have take our n, and then we have run a loop from 1 to n minus 1, then take our edges x and y, and we have push x and y in graph, that is adjacency list, and we have take id or index of xy is I or yx, we have take vice versa, and n is not divisible by 3, then we have just report that answer is -1. Otherwise we have called a DFS, which is a node and its parent, right? For one, parent is 0, and this DFS we have just visited node is equal 1, and for this okay means our result, okay equal false, that means our result is not possible, that means result is -1. We have write this for a indicator, and we have take a vector which is name is b, and we just iterate for all connected vertices with this node, and if visited then we have not doing anything. Otherwise we have stored its size, right? Node size. If size is greater than 0, then we have just push in our vector. Now if your vector size, that means vector means this, right? For 1 it is 2 1 1 1, right? For this tree, for 2 1 1 1, for 3 it will be 1 and 1, for 3 let me write for everyone. For 2 it will be just for 2, come here, for 2 it will not go uh, it will not go there, so just the size will be 0, so we'll just return 1, right? So for 2 vector size is 0, for 3 vector size is 1, which is contains just 1. For 5 vector size is 0 again. For 4 vector size again 0. For 6 vector size is again 0, right? That means if our vector size is 0, then we just return a 1, that means size of this subtree. Just so I have just doing this here. If vector size is 0, then return 1, that means size. If vector size is 1, that means my node vector size is just 1. So if this is true, then there is a there is a branch, right? So I can this node, I can cut this node and parent branch, parent edges, right? So I have done this. If vector size is 1, if first element or the only element is 2, then I have uh, push the age, right, id of node and parent in a vector which is answer, and I have just written 0, right. Otherwise, if my vector size is 1 but first value is only value is 1, that means the vector the subset size will be 2, because 1 for the children and 1 for the node, so child will be 2. And otherwise the answer is not possible, so I have change indicator okay equal false, and I have just written 0. If vector size is 2, right, if vector size is 2, then it is for sure that my uh, subtree size should be 1 and 1, right. So I have just checked b0 equal 1 and b1 equal to 1. If that, then I have just stored the id, node and parent ages id, then I have just written. Otherwise I have say that okay it is false, I am written 0, right. So yeah, then I have just pop back. So our answer is ready. If okay is not true, then our answer is -1. Otherwise I have pop back for from answer. It is why 1 is connected with 0, I have taken also this, so this is not true. So I have just written I have just popped this 0 from here, and I have just pinned it. You can do it for yourself using pen and paper. So that's it. Best of luck for you for the next bit. Best of luck for your competitive programming life, and pray for me. Assalamu alaikum. Tata.